Hi everyone, today we're going to continue with chapter 3, the part 2. Okay, so in this chapter you will learn all of this which we will go through one by one. Okay, first we're going to learn about what is the derivative as a rate of change. Okay, so here derivative is used to signify the rate of change, right? So velocity in bahasa Melayu is halaju. Halaju, right? So this velocity is also the derivative of position with respect to time. So position is s. Okay, so if a body position at time t is s ft, then the body velocity at time t is, okay, so this is the equation for the instantaneous rate of change, right? Okay, so for velocity it is only at a particular time. Okay, to find only at a particular time. However, for speed it is the absolute value of velocity. Okay, it is the speed for all. Speed is also laju, which is for all times. Okay. Okay. And acceleration is the derivation of derivative of velocity with respect to time. Okay, it is also the d square s is position over dt square, since this one is acceleration and this one is also acceleration. I think I'm not making any sense here. It's better if we start with the example. Okay, let's see for example 1. So for example 1 here, the position in meters of a marble rolling is given by s equal to 100t over t plus 1, where t is measured in seconds and s equal to 0 is the starting point. So the question is for us to find the velocity of the marble. Velocity of the marble. So now let's look back at the equation. Velocity, which one is velocity? Is ds over dt. Okay, so velocity is ds over dt. Okay, now we have s is 100t over t plus 1, right? So now we want to find the derivative for ds with respect to time, right? So it should be ds over dt for this one here, right? So looking at this equation, you can see it is a rational function. Okay, where there is a numerator and denominator. So which formula should we use, guys? Remember? Okay, we should use this one. vu prime minus uv prime over v square. Okay, where u is 100, t and u prime is, sorry, it should be here. Okay, u prime is 100 and v is t plus 1 while v prime is 1. Okay, so just slot in this value together. v u prime, t plus 1 times 100 minus uv prime, 100t times 1, right, over v square, t plus 1 square. Okay, so I'm going to continue here. So 1 equal to 100 t plus 100 minus 100 t over t plus 1 square. So this two can be cancelled together and the final answer is 100 t plus 1 square. So this is the velocity. This is the ds dt for the marble. Okay. Okay, this answer question 1a. So now we're going to try to solve question 1b. So question 1b is at what time is the marble is 80 meter from its starting point. Okay, remember starting point is at 0 meter. So when the marble is 80 meter from its starting point, what time is it? Okay, so now, so for B, we want to find what? Class T. We want to find T given the value of what here? 80 meter is S. Okay, so S 80 meter, what is T? When S is 80 meter, what is T? Okay, we have this equation here provided by the question. So S is 80 meter and okay, this is just simple algebra. Okay, try to do it yourself and see whether your answer is similar to mine or not. Okay, so this one should be 8. Okay, no need to write meter, right? Okay, 80t plus 80 equal to 100t. So 80 is equal to 20t. So t is 4 seconds. Okay, why second? Because in the question it is stated t is measured in second. Always remember to check the question first, to check the unit. Okay, okay, so this answer question B. Okay, now we're going to try to solve question 1C. Okay, okay, what we want to find here is find the time when the velocity is 50 meter per second. So find t given the velocity is 50 meter per second. Okay, so now what is the formula for velocity? Let's look back at the notes again. Velocity is this one. So velocity is ds over dt. Velocity is ds over dt equal to 50 meter per second. So ds over dt we have already solved, right? In question 1a, kan? So ds over dt is 100 over t plus 1 square equal to 50. Okay, equal to 50. Now we want to find t. Can or not? Can kan? Easy, right? Okay, so this should be t plus 1 square equal to 100 over 50 kan? So you will get 2t plus 1 square. Okay, so looking at this, we try to solve it like this here, t square plus 2t minus 1. So 2 square, t square plus 2t, no, this is plus 1, okay, minus 1 equal to 0. Looking at this, we cannot factor it using the simple question. A simple formula, you have to use this. B square, remember? No, there is no square here. 4ac over 2a. Okay, you can use this equation to find the value of t, or you can solve it from here. Okay, so t plus 1 square equal to 2. We can remove the square to this side, so it will become third 2, right? So t is plus minus third 2 minus 1. But the answer is only third positive third 2 minus 1, because since time cannot be in negative units. Okay, so this answer question example 1b. Okay. Hi. Okay, so now we're going to solve example 2. Okay, says here in the question, a ladder 10 feet long rests against a vertical wall. Okay, ni ladder. Okay, ladder 10 feet long. If the bottom of the ladder slides away, ni bottom ni, bottom slides away from the wall at a rate of 1 feet per second, so dx over dt is 1 feet per second. Okay, it is sliding away at a rate of 1 feet per second. How fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet from the wall? Okay, how fast? So how fast is this is y and this is x. So when x is 6, we want to find what is the dy dt, how fast. Okay, so now we have here this x square plus y square. Why? This is the Pitagoras Theorem. We can also apply it here, 10 square, and then we also have here dx over dt is 1 feet per second, and also we know that x is equal to 6 feet. Now we want to find dy over dt. What we can do is we can differentiate both sides of this equation in respect to t. So the d dt of x square plus y square equal to 10 square. Okay, so looking at this, how can we solve it? We have to use the implicit differentiation. Okay, so 2x dx over dt plus 2y dy dt, and this one you should get 0. Okay, so now we have this equation dx over dt. Do we have the numbers here? I don't know, there's some problem with this. Okay, and this. Okay, sorry. Okay, example 2. Okay, so I think I have to rewrite this again. So as I said earlier, I hope it was recorded. I really hope it is recorded. So this is a ladder 10 feet resting against a vertical wall, right? So the ladder is sliding at a rate of 1 feet per second. So the sliding is termed as dx over dt per second, 1 feet per second. So the question is, how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet from the wall? Okay, when this one is 6 feet from this wall here. Okay, so now this one should be y and this should be x. Okay, so we know that x is, when x is 6 feet, and the dx dt is, this is the information that we gain from the question. Also we know that and we want to find dy over dt. Okay, we know that x square plus y square equal to 10 square. Why do we use this equation? This is the Pitagoras Theorem. Okay, so we differentiate both sides. With respect to t. Okay, so this is the implicit differentiation. 2y dy dt equal to 0, right? Okay, so we know that dx, so no, this is not dy, this is dt, right? Okay, we know that 2x. We know that dx dt is 1 plus 2y dy dt equal to 0. Do we know what is the value of y? Can we find it from here? We can find, because we know the value of x. Okay, so x is 6, so 36 plus y square equal to 100. So y square is 64 and y is 8. So now we know the value of y plus okay. Do we know the value of x here? Yes, we do. X is 6. Okay. So should be 12 plus 16 dy dt equal to 0. So dy over dt is minus 12 over 16, which is equal to minus 3 over 4 feet per second. Okay, because it follows this feet per second. Okay, it follows the same unit as dx over dt. So now we are going to solve example 3. So example 3 tells us that assume that oil spill from a ruptured tanker spreads near the tanker. Oil tank spreads at a circular pattern. Okay. Calculate the rate of change of the area when the radius is 60 meter at a if the radius is increasing at a constant rate of 2 meter per second. Okay, we know that r is 60 meter. We know that dr over dt is 2 meter per second. What we want to find here is the rate of change is dA over dt. Okay, we know that A is equal to pi r square, right? So this can also be represented like this, d dt of pi r square. So pi can put outside, and this one should be like this, just the d dt of r square. Okay, so okay, 2 pi r and the d dt of of r is so, and r is 60 and dr dt is 2. So the answer is 240 pi meter square per second. Okay, so now I want you to do example 4 where the answer is 120 pi for A and for B is 5 cm. This follows exactly the same method like example 3, I guess. So yes, if you have any question understanding my lecture video, please let me know. Okay, bye. See you guys.